right, as we're introducing you to different types of chemical processes, different chemical reactions, another one that is really important is acid-base neutralization. And neutralization reactions do the same type of chemistry, they do the same type of rearrangement that we see in the precipitation type reactions, where we do this kind of double displacement, where both of the species that we react together on our reactant side kind of swap partners. And the reason that they do that is because acids and bases act like electrolytes. So an acid has a low pH. If we're thinking about kind of the pH scale, which we're all pretty familiar with, because a lot of us have taken at least some sort of chemistry or biology or physical science classes in the past where we had to do some sort of measurement of pH. So acids have a low pH, and we think about them as anything that donates a hydrogen ion to the solution. So anything that puts a hydrogen ion in solution we could call an acid. And we'll get into more detail on acids and bases and the different chemical definitions in later videos. This one is just to talk about the neutralization reaction itself and how it relates to kind of the double displacement process. So a base then is on the other end of the scale. It tends to have higher pH values. And when we're thinking about what a base puts into solution or what makes a solution basic or alkaline, then it's something that donates an OH. OH minus here is the hydroxide ion. It's one of the polyatomic ions that's very common. And so if I have this hydroxide ion in solution, then that means that it's a base. Now, when I say they act like electrolytes, this goes back to the Ionic theory of solutions that was put forward by a man by the name of Svante Arrhenius. So here's the last name. Svante Arrhenius was a really important chemist. He had his hands in a lot of different things, but he was looking at solutions and the Ionic theory of solutions, and he said that ionic compounds will dissolve in solution and separate into their component pieces. And so an electrolyte is anything that puts ions in solution. So I could have an ionic compound that dissolves. I could also have acidic or basic compounds that put these ions in solution, and they are electrolytes. And the reason it's called electrolyte is because it allows for the movement of electrons when I have charged particles that are floating around in my solution. So these electrolyte solutions then can conduct electricity. This is why that's why it's so dangerous to have electrical appliances around water, because of all the salts that are in it. Even if you don't have really hard water we think about as stuff with dissolved ions in it, and those dissolved ions come out on our tile and such. Even if we don't have really hard water, we still have some stuff in it, and those ions in solution allow for it to conduct electricity. Okay, so with acids and bases then, acids and bases also dissociate into their component pieces. That's kind of the key to an electrolyte solution, is that it splits into ions. And so a neutralization reaction is going to do that same type of chemistry, where we have that AB plus CD is going to give me whatever I have. A is going to pair with D, and then C is going to pair with B. So this is called, again, a double displacement reaction. It's also called a metathesis reaction. So we're swapping partners, essentially, and the cation from one is joining up with the anion from the other, and vice versa. So we can predict the products in a neutralization process then. HCl is hydrochloric acid, so this is an acid. Hydrochloric acid is one of the primary components in your stomach acid. And then sodium hydroxide is a base. And again, we'll get into definitions here of how and why we can recognize these things. One of the things you look at here is the hydroxide paired with a metal cation. If we have a metal cation with a hydroxide, that's going to be a base. If we have a compound that starts with a hydrogen here, it's going to be acidic, and you'll kind of get to know them because there's a lot of common ones that you'll see and be using a lot of in your chemistry careers. So when you react together an acid, which is on the low end of things, and a base, which is on the high end of things, when we're thinking pH scale here, then my first product that forms is my AD product. So let's think about this in terms of dissociation. Aqueous compounds mean that we are dissociated into our component pieces. So that means I have a hydrogen and a chlorine from my hydrochloric acid, and I have a sodium and a hydroxide from my base. And now we're going to switch partners. So the hydrogen hydroxide then gives me two H's and an O. That's water. And then the cation from my base and the anion from my acid gives me sodium chloride. Sodium chloride is soluble. Water is a liquid. We would know this from our solubility table and just from our daily life because we know what sodium chloride is. It's our table salt, and water here is the environment in which this is all occurring, so we're making more water from this process. And this is going to be true of any acid-base neutralization reaction. I have an acid and a base. I form water and a salt. And salt in this case just means any ionic compound that forms, although this one literally is table salt. But as inorganic chemists, we talk about salts as just ionic compounds. So we have a metal cation and a nonmetal anion that are paired together and form in these types of processes. So we have the same kind of double displacement. We flipped partners, we end up with water and a salt. We started off with something low pH, reacted it with something with higher pH, and ended up with water, which is right in the middle. Hence neutralization reaction, because we're at more of a central pH because of the water. And then the salt in there is also dissolved, so it just has sodium and chlorine ions hanging out. If we're thinking about this in terms of a net ionic equation, then the liquid form stays together. The sodium chloride is still sodium and chlorine ions. Right? It's aqueous or aqueous, which means that these ions are still in solution. So if I think about the net overall process, I have some spectators, right? I have a sodium ion on this side, I have a sodium ion on this side, I have a chloride ion on this side, I have a chloride ion on this one. So those guys are just hanging out. They stay as these ions on both sides of my reaction. So my net take-home message from this reaction is that I have hydrogen ions reacting with hydroxide ions to give me water. And this is an incredibly important reaction, even though it looks a little bit kind of intuitive, right? Of course water forms with all of this, but that's why it's important. It's a neutralization reaction. This is the acidic part, this is the basic part. We end up with something in the middle. And again, we'll get into more detail on acids and bases later. This just kind of gives you another example of net ionic equations, these double displacement reactions where we're doing some interesting chemistry there, and then kind of what is the whole take-home message. Okay, if you have any questions, feel free to reach out. Otherwise, I'll talk to you again soon.